I am Dr. Asad from Department of Community Medicine. Today our session is on sample size calculation. Research is done to find a solution to a particular medical problem formulated as a research question based on statistics. In an ideal scenario, the entire population should be studied, and which is almost impossible. Other than census, which is conducted in each and every person of the population, all other studies are performed on limited subjects drawn from the concerned population, known as the sample population. The data obtained is analyzed and conclusions are drawn, which are extrapolated to the population under study. So from sample, it is generalized to the population. The purpose of this session is to highlight the need and importance of sample size calculation, which should be performed before starting any study. This word should be underlined: before starting any study. So what are our learning objectives? These are: discuss significance of sampling and research, to list basic assumptions in sample size determination, understand implications of sample size for different study designs, determine the sample size required to estimate a single population mean at a given level of accuracy and bound on the error of estimation, determine the sample size required to do hypothesis testing of a single population mean at a given level of significance and power of the test. These are the references: Fundamentals of Biostatistics by Bernard Rosner and Blumen. These are Blumen is very easy to read and understand, and I recommend it for our new students. So and don't get bogged down by these verbosity of the words or the learning objectives. They will be very simple when you go and read about them. So sample size calculation for different study designs. So basic thing is that the basic prerequisites are same for all sample size calculations, either for cross-sectional studies, cohort studies, case control studies, randomized control trials. So what makes them, why different formula are needed? The different formula are needed because of the different methodologies used in designing the studies. For example, the sample size required for a cross-sectional survey of hypertensive patients will be different from the sample size required in conducting a randomized controlled trial, because in randomized RCT there are two groups and the sample size will include statistics for that group as well, so the formula changes, right? What are the different assumptions in calculating sample size? That the sample is derived from a finite population. It is not from any infinite population, because then it will be very impractical to gather any statistics about it. And it is from the sample is from the normal distribution. That is, all the members are normally distributed. The characteristic of the interest is normally distributed. It is not skewed either positively or negatively, because skewness will result in wrong information. Now, importance of sample size determination. Importance of sample size determination can be seen by the words from the Bartlett. He is a very well-known statistician, researcher, and different other ventures he's involved in it. he said that the determination of sample size is a common task for an organized research. Inappropriate, inadequate, or excessive sample size continue to influence the quality and accuracy of the research. So, these words from well-known researcher throws light on the importance of sample size determination. And what is the significance of sampling in research? Inadequate sampling is unethical. Answer research questions relatively more accurately if done properly. So, when we talk of inadequate sampling, then this inadequate sampling can be it can be too small, it can be too large, or it can be unethical. So, the study on small sample is quite tempting. The researcher wants to do it as early as possible, and it's obviously feasible, but it is a waste of time and money, as the result will be invariably inconclusive. Very often, small sample size, very often, small sample size, they lead to underpower studies and will be able to detect the differences that is being investigated. A very large sample size is also not recommended, as it has its own consequences. For example, it's a waste of the limited available resources in terms of time and money when an answer can be accurately found from a smaller sample. Secondly, recruiting more subjects than required can also be termed as unethical, as the patients participate in a study with faith and a good motive that he or she is serving the community, which should not be misutilized. Thirdly, in a randomized controlled trial, more people will be denied a better regimen and will get a placebo or an inferior treatment with its associated side effects. These valid reasons are enough to justify proper sample size determination before the start of any study. And all these can lead to poor quality research. It will be filled with errors. And this research obviously cannot be of any use to the people or the community. So, how to determine sample size? There are different formulas. Researchers and statisticians develop formulas. There are two main areas of sample size determination: estimation of parameters, hypothesis testing of parameters. So, parameters are basically the characteristic of interest in population. When it's comparable to the characteristic of interest in sample, which is known as statistic, right? And hypothesis testing, hypothesis is basically a claim, right? So for the ease of researchers, tables and softwares for sample size are available, and the most common softwares that are available are WHO sample size calculator, which is easily available, freely available on Google. You can search and load down and download it. And the API info, NCSS pass, and A cluster for randomized controlled trial. These are now before going into population. Let gets familiar with a few words. Population. The term population means all the data points of interest. All the population. For example, all Pakistanis. Target population, for example, the population, for example, you want to study the hypertensive patients, male hypertensive patients more than 60 years of age. So your target population will be males more than 60 years of age and hypertensive. Your study population will be the sample from the target population, right? So, what are the basic concepts in sample size calculation? There are different terms, the technical terms that are used in the jargon that is used in calculating the sample size. These are study variable, study hypothesis, and parameter of interest. A study variable is anything that varies, and there are different types of variables: the continuous variables, the categorical variable, independent variable, dependent or the outcome variables. And let's see few examples. What is the average amount of salt in the diet? So amount of salt in the diet is the variable. What is the prevalence of repetitive strain injury of back among computer professionals? So RSI, or repetitive strain injury, is the study variable. Study hypothesis, as I've said, the hypothesis is a claim, and the two types of hypothesis: null hypothesis and the alternate hypothesis. Null hypothesis usually says that there is no difference. Alternate hypothesis says that there is a difference. But let's see what's the example. Average number of leaves taken due to strain injury is at most 15 working days per year among workers at shipyard. Here the researcher is making claim that due to the strain injury, at most 15 working days are taken as a leave by the workers at the shipyard. Parameter of interest. So the average amount of salt in the diet, prevalence of SRI, uh, of injury of back among computer professionals, average number of leaves taken due to strain injury. These are the parameters of interest. These are the characteristics that we want to that we want to investigate. So there are other errors as well. Whenever you are doing a study, you are bound to have errors, and these errors are the different types. The type 1 error, which says that rejecting the null hypothesis when the null hypothesis is true. It's usually 0.05. Alpha, the type 1 error rate. Type 2 error, failing to reject null hypothesis when null hypothesis is false. It's denoted by beta, the type 2 error rate. Power of the study is very important. Power of the study says the ability to detect the difference when there is actually one. The probability is the ability to detect a difference when it actually exists. Margin of error. So no sample is perfect. Whenever you are taking a sample, there is bound to have some errors. These errors, or mainly it's known as the margin of error, and researchers usually keeps it at 5%. Right? They take risk of only 5%. That if the 5% error is acceptable to them, right? It's decided before the study design, before conducting the study, and since it is already fixed, it's really it's very unlikely to have a negotiation about it, because usually it is in statistical inferences, in statistical books, it is fixed. Confidence level: how confident you want to be. How confident you want to be that the parameter or the characteristic or the answer that you have find out is within the given limits. So most of the time the confidence level is or the confidence interval is fixed at 90%, 95%, 99%, and like in margin of error, the larger if you keep the margin of error more, right, your sample size requirement will be less. But if you keep the margin of error small, sample size will be large. Similarly, confidence level: if your confidence interval is more, if you want to be more confident and you need more sample size, the sample size will increase. And if you want to have a smaller confidence, lower confidence, say 90% confident level, then your sample size will decrease. The population variability. More variation, the better. For example, because if there is more variation, more heterogeneity, the more representative the sample will be. If you are conducting a study in a metropolitan city or in a metropolitan society, then you can generalize the results to the different entities that you have recruited, as compared if you are conducting it in a village or in a goat which has a very homogeneous population. So it will be very difficult to generalize it to the general population. So what is needed while calculating sample size? Sample size is usually calculated for the population mean or population proportion and the hypothesis testing, or the testing a claim about the population mean or a proportion. So number one thing is identification of the major study variables. For example, if you are saying that the consumption of salt results in stroke, so this will have one can say that there are other variables as well. For example, family history, for example, high cholesterol levels, for example, physical the person is not very much physical, so lack of exercise. So true, these are, but you have to identify, since you have in your research question is about the consumption causes stroke. So consumption so the use of salt, consumption of salt causes hypertension. So the consumption of salt is your major study variable. Decision about confidence level, alpha level, usually we take it as 0.05 and 95% confidence interval. Decision about closeness of expected mean to the actual mean, bound on the error, bound of error. Bound of error is similar as the marginal error, and we want it to make it as close, as small as possible. Expectation about possible variation for the data or the population variance, standard deviation, expectation that about possible variation for the data, standard deviation. Anything additional? Do you think that we are missing something? That's very important. We have talked about 1 minus beta in our earlier slides. So power, the decision about desired level of power, 1 minus beta, and usually it's 80% and it's fixed. Sample size formulas for estimation. Sample size formula for the estimation of population mean. So let me state it before going into the further slides, that you do not need to memorize any formula. You do not need to memorize any formula. These formula will be given to you during your exams. What you need to have is a grasp of concepts. What are the different terminologies and how they interrelate, right? So let's delve into the formulas. N naught is equal to Z alpha by 2 whole square, sigma square, which sigma is the population variance, and B square is the margin of error or bound of error, where N naught is the minimum sample size required, alpha is the level of significance, usually 0.05 or 0.01, value minus 95% from 0.95 from 100, you get 0.05, and you minus 99% confidence interval, or 0.00 0.99 from 100, you get 0.01. B naught, and then we have Z alpha by 2. Z alpha by 2 is the value of Z at selected level of significance, right? And population variance of the selected variable. Of course, the selected variable is with the outcome variable, the variable that you want to find about. Note, if the population standard deviation is unknown, then range of the variable could be used to estimate population standard deviation. And here, if the population standard deviation is unknown, then population standard deviation can be known from by dividing range by 4. If sample size for the estimation of population proportion is required, then population variance will be replaced with PQ in the above formula, where P is the expected probability of success. If P is unknown, then use P is equal to 0.5 or 50%. We will see why we are using P as 50%. B is the acceptable bound of error, the minimum absolute difference between actual and anticipated mean or proportion. The value of Z or Z score corresponds with your chosen confidence level. The most commonly used are 90%, 95%, and 99%, and their corresponding Z values are 1.64, 1.96, 2.58. These are the three confidence intervals which are most commonly used, and it's very easy to remember these. Why P is equal to 0.5 or 50% when unknown? You can see in the table as well that when the P is 0.5, the variance is 0.25. It is the highest variance we get is at the 50% proportion. So you can so the maximum variance resulting in maximum sample size, when other requirements including confidence level, bound on the error, power of the study if required are fixed. So in the table in the table on the left, you can see that 0.5 is corresponding to the highest variance, population variance, that is 0.25. So this gives us the maximum sample size. Let's have a few examples. Suppose we need to estimate the mean serum cholesterol level of a population within 5 mg per deciliter of true mean. We learned that population variance is equal to 20, and we want to estimate with 95% confidence that X, or the sample mean, is within 5 units of mu. So we obtain N as follows. And the formula is, if you have a look at it, we have alpha, we have the value of alpha by 2, alpha population standard deviation, that is 20, given in the question. We have d square, the value is 5, and 95% confidence interval. What we need to know is the value of the Z alpha. And how we calculated Z alpha? We know that alpha is equal to 1 minus confidence on the right side. If you look at alpha is equal to 1 minus confidence interval. Alpha is equal to 1 minus 0.95. If the confidence interval is 95%, we convert it, divided by the 100, it will become 0.95. 1 minus 0.95 is equal to 0.05. And when we divide the 0.05 by 2, that is alpha divided by 2, we get 0.025. And when we look at the corresponding number in the T table, in the Z table, it's 1.96. So you people need not to worry about memorizing the formulas or the tables. All will be given to you. And yes, the sample size that we by putting all the numbers in the formula, we come to a sample size of 61.46, and obviously the fractional sample sizes are not practical, so we round up to the next number and obtain a sample of 62. And another important thing is that if the population variance is not known, we calculate it by sample standard deviation. Second example, suppose you want to estimate the birth weight of children born to non-smoking women in the community within zero point 0.2 of its actual value with 95% confidence. Assume the standard deviation of birth weight is 0.5 kilogram. Find the required sample size. So again, putting it in the formula, n is equal to z alpha by 2 square sigma square d square, and driving the confidence interval and z alpha by 2 in the same way we have derived it in the previous example, and jotting all the values, we get a value of 24.01, and obviously 24, rounding it to the upper number, we get 25%. At least 25 is required, as 25 women are required as a sample size. So amount of salt included in person's diet during 24 hours. A nutritionist wishes to estimate with 95% confidence the mean amount of salt included in a person's diet during a 24-hour period. She wishes the estimate to be within 5 units of the true mean. From the previous work, she has learned that the range of salt amount consumed per day is 40 microgram. So what are the various numbers that can be identified from here? That the 95% confidence, so alpha is equal to 0.05, alpha is equal to 0.05, 5 units. She wishes the estimate to be within 5 units of the true mean. So 5 units means that the margin of error, the bound of error is 5. From the previous work, she has learned that the range of salt amount consumed per day is 40 micrograms. So here population variance or sample standard deviation is not given, only range is given, and we have seen in the previous slides that if range is given, then we divide the number by 4 to get to make it equal, or to make it approximate to the population variance. So let's go on. 1 minus alpha, this is the same that we have derived 0.025 as said earlier. Similarly, the z alpha, range 40 microgram, and when we divide the range by, we get 10 by population standard deviation, population variance, it approximates 10 microgram. B, 5 units, absolute difference between actual and anticipated mean amount of salt including a person's diet. And then when we put it in the formula, we get 16% sample size of 16%. Now conceptual computation of sample size for testing of hypothesis. Now we are moving towards the hypothesis testing. That was about the estimation, right? That there we have, in the previous slides we have estimated the mean and the proportion of the parameter, right? And here we are computing the sample size for hypothesis testing about population mean. There are two types of hypothesis. One-tailed hypothesis, which says that null hypothesis. One-tailed hypothesis means either in the positive direction or the negative direction, either an increase or a decrease. So a null hypothesis says that the mu is population mean. Mu is more than mu naught. Sample mean is more than population mean. And alternate hypothesis says the reverse. The mu is less than mu naught. Or mu or H naught hypothesis, null hypothesis, is mean, the sample and the population mean, they are examples. So if one-tailed hypothesis, again it says this is the one-tailed hypothesis for about population proportion. Previously we have calculated it for the population mean. So if one-tailed hypothesis says that the one-tailed hypothesis, then again it will be either increase or decrease. So and they will be going into the opposite directions. Where prevalence of anticipated prevalence. So P is the prevalence, anticipated prevalence, and P naught is the prevalence in the population. When you put it into the formula, you will get the you will have your sample size for the required question. And in two-tailed hypothesis, again you will divide z alpha by 2. At this point, don't get bogged down by all these numbers, all these formula, right? They will be much easier for you. It's just to sensitize you, it's just to sensitize you to these concepts, to these formula. You will be able to do it more easily, and we will be giving you sessions in much detail in your future classes. Now, another example is that of the repetitive strain injury of back among computer professionals. How many computer professionals should be sampled to test the hypothesis the prevalence of back pain in the computer professionals is 12%, against the alternative that it is not 12%? The investigators wish to be at least 80% confident of detecting a difference of 8 percentage points or 8% or more in either direction at 5% level of significance. So for any question, hypothetical question, first jot down the clues or jot down the numbers that are given to you. So null hypothesis says that the prevalence of back pain in computer professionals is 0.12, and alternate hypothesis says no, it is not 0.12. Similar that we have calculated earlier on. So 1 minus beta, 1 minus beta, as we know that it's normally 80%, and when we minus 0.8 to minus 0.8 to 1, we get 0.2. Z beta is equal to z.2. Its value is, don't worry about from where the 0.84 came upon. It is from the tables that are there. Beta b is equal to 8% or 0.08. The absolute difference between actual and hypothetical prevalence of repetitive strain injury. P naught is equal to 0.12, and alternate P is equal to P naught plus minus beta. And why they have given plus minus beta? Because P naught says that it is 0.12, and we have to combine it with the 8% or 0.08, the actual prevalence, which gives us the value of 0.04 or 0.20, and we will take 0.20 because it has the largest variance. And this is also true whenever for example, if you are doing if you want to study the prevalence of dental caries in children, in school children, and you find out, you want to calculate the sample size and you want to know the prevalence. Obviously for sample size calculation you need the prevalence of your, for that survey you need the prevalence for you calculating the sample size. You come up a study, different studies, which says that the prevalence varies from 2% in some studies, 4%, in one 8%, in other 10%. So what prevalence you will choose for your sample size calculation? Like here you will choose the maximum prevalence that is reported, the maximum reported prevalence for calculation of your study design, right? Study sample size calculation. So this, putting it in this formula will give you 147.9 or 148 rationals that are required. Adjustment of the calculated sample size. Now why we need to adjust once we have calculated the sample size? Now what are the different adjustments we need to do and why we need to do? Right. So let's see. Using approximated design effect from similar kind of a study, using design effect to 1 if simple random or systematic sampling techniques are used to select the same subject. So to simplify it, so the design effect is the effect which is usually incorporated into sample size calculation if there are some sort of issues in sampling techniques, right? And normally these are normally we choose the design effect of 1.5 or 2. It will increases the sample size and thus takes care of the problems in sampling techniques, right? And like the simple random or systematic sampling techniques, there are different types of sampling techniques you will be studying in your future, in your next class, right? And using expected response rate, obviously when you and using expected proportion of eligible persons, when you see that the okay, in this community I want to have 100 questionnaires from 100 smokers, and you know the expected proportion of eligible persons, that okay, from these in this community the eligible ones are 150 and I can easily get the 100 ones from there. So you don't try to change your sample size, but you see, if you see that I need 100 but the person are not more than, will not be more than 80, then I will have to adjust either my sampling design technique, my sampling design, or my sample size. And using expected response rate, for example, if I am going into a community and I want to know the prevalence of smoking among women, then I, from the previous studies or from their cultural knowledge, I can assume that I will not get the required response rate, or I will not get the required sample. So what should I do? And you see, adjustment of the sample size, calculated sample size, is not all about statistics. You can increase, for example, including the design effect, you can increase the sample size, but what if the response rate is very low? If the response rate is very low and your required sample size is you are finding it very difficult to reach your required sample size, then there you will go to the community, you will go to the influentials in the community, you will go to the women head of the household, you may go to a school teacher, you may go to a mosque imam of the mosque, or any influential leader the people here the people respect, those who respect who people respect, right? And by that you can increase your response rate. And using survey cost per case, or obviously you have to adjustment, you see, adjustment does not mean increasing the calculated sample size. Adjustments also mean decreasing the sample size if it becomes difficult. For example, if the survey costs are higher, then you may not need not to, you may have to limit down your sample size. And there are limitations of the studies. These are the limitations of the study. Sometimes it's very difficult for you to reach the population, like in earthquake affected areas or in disastrous areas. So that's your limitation, and you have to live with that. Now, what is the relationship of sample size with confidence level, variance, power of the study, and bound on the error? These are the basic ingredients of sample size formula. So sample size is directly proportional with confidence level, variance, and power of the test. So higher the confidence level, the higher will be the sample size. For example, if you go with 90% confidence interval and compare it with the 99% confidence interval, the more confident you want to be, you have to pay the price. You have to have the you have to increase your sample size. Variance, the more variance you need, the more variety you need, the more heterogeneity you need in your sample size, the more the increase in sample size be the call of the day. And the power of the test, obviously, if you really find out the difference, if there exists one, then you again have to it again have a cost. You have to increase your sample size, and sample size inversely proportional with bound on the error. The more you want to be close to the actual mean, the more, or the margin of error, the more you want to be close to the actual mean, the more sample size you require, and the less uh, and the less the less error you want to bear, the more sample size will you need, and the more error you want to tolerate, the less sample size is required. So they are inversely proportional to each other. So that's about what we have to say, ending on the morale of the story. So let's review the researchers and the reviewers' point of view. Researchers always determine how many measurements you need to take in order to have high enough power to achieve your study goals. And what the reviewer has to say. And if you don't know how to determine sample size, ask a statistical consultant to help you. Right? And we have statistical statistician available within our department, and we are here to help you out. We are happy if you conduct some studies, and we will be with you. When interpreting the results of a study, always take into account the sample size. So this is very important. While reading it into the research studies, whenever you are reaching a research article, or whenever you are looking at the results of a study, do look into the methodology section and look at how the sample size was achieved, whether they have taken into account all the ingredients, all the elements that are required for calculating the sample size, or they have just calculating it conveniently from some other studies, taken from some other study, because that same study has also the similar sample size that they are now replicating. So do have an eye on it. So now, thank you so much for your attention. Thanks.